why this matters and what's going on in the environment to cause this to matter. And as Rhonda said, I'll give a few slides and then we'll switch to demo because demo is always more fun. So what is this multi-platform all about and why are we having this discussion? If we look at the environment today, we have our systems of engagement and we have our systems of record that can come together as a system of engagement. And these systems are generally built differently, developed differently, under different cycles, under different development processes. And we're not necessarily spending the right time in the right place on the right applications. So we're spending a lot of time doing maintenance for systems of record that maybe we shouldn't be doing, i.e. we're working on something that is not of high business value to the company. Or I'm doing functions of my back-end system, but I can't do that fast enough to provide the value to the company. Or my projects, I can't do them concurrently. I have trouble doing the concurrent work that needs to be done. While in the front end, with the systems of engagement, we have teams building applications, doing updates, making changes in a continuous fashion, trying to get those updates out because, as everyone knows, they expect a mobile update within hours, not within weeks. And so this in systems of engagement, systems of record coming together adds to the challenge of development and of deployment. And then add to that the cloud-based services, so the API economy that's providing additional services that you might want to provide into your applications to provide that business value. And so we need to bring these systems together in a better way. Over time, the systems of record have developed a set of procedures that are there for a reason. They're there to reduce risk. They're there to reduce risk by reducing the number of deployments. But if we can improve the development process, the deployment process, then we can increase the deployments while still reducing risk. And so it's important to look at this whole environment and see how we can improve this process. And that's how we get to the IBM DevOps point of view. It's critical to understand that with DevOps, it applies just as much to our systems of record as it does to those systems of engagement. Understanding what you should be building is the first step. Making sure that you really are spending effort and dollars on the applications that matter. Making sure your development environment is collaborative and that all teams can work together to provide function. The idea that the front-end teams and the back-end teams can work together in the same tools, in the same processes, help improve the development process and bring value faster. Continuous testing, automated testing, ensuring that you have automated regression buckets, doing things such as test-driven development to make sure you have the test case before you even have the function, making sure that you have the ability to test in an efficient manner, in an automated manner, so that as you're doing your continuous deployment into the environments, test, dev, you can test those and ensure you're meeting the quality that you expect in the environment. As you improve the automation and the flow from the collaborative development through testing, through deployment, you get to the point where release process, as in the deployment into production, has been done so many times already in the same automated way that by the time you're getting it, deploying it to production, risk is reduced. Also bringing continuous monitoring, bringing operations into development so that the monitoring is done in exactly the same way, so that the operations team is working with the development team to define the deployment capability and the release capability, such that when you're deploying and releasing, you're doing it exactly the same way, from dev through test through production, no matter what platform. And ensuring that the operations teams are full players in this environment, such that the system test, the integration test, all the way to function test, the monitoring is done in the same way it's done in production, so that you can define the monitoring characteristics of the application as well. All of this is deployment. All of this is development. All of these things need to work together, whether or not you happen to be in development or in operations. When we talk about bringing these teams together to provide this continuous feedback and optimization, we're talking about bringing the teams together so they can work together. But there's nothing about necessarily tearing down the organizations. We understand the separation of duties, it remains critical. It's important to make sure the right people, the right authorization checks are in place. But you can do that while having teams work together and collaborate and ensure you're getting the feedback that you need. And as we bring together these teams, the culture, the processes, the development process, the operations process, as we bring these teams together, they can work together to deploy the applications as needed. And you may easily end up with significantly more releases on the front-end systems of engagement. While you have fewer releases in the systems of record, you still need the teams to work together so that they can collaborate and provide value. One of my challenges in this picture is to help make sure we get to the point that our deployment process or our delivery pipeline, the ability to build function, test it in an automated fashion, and get it deployed becomes so fast that there is no longer a need for the emergency change process. I don't expect that that process definition will go away, but if you can truly make a change and automate the testing for it such that you can get it deployed in the normal manner, you won't have to use the emergency change process, which will reduce risk within organizations and improve the reliability of the production environment. So as we drill down into each one of these areas, we start by having the teams work together. So making sure you have the ability to define the user requirements, to make sure that users can specify what needs to be built, clearly specify the requirements for the application, and then provide a feedback loop early on based on even the requirements to make sure you have iterated on them so that you know you're building what you expect, fully integrated into the development environment so that as you're building the function, it's tied to those requirements and you can continue to get that user feedback on the function you're building. And then making sure that all of your tests are properly managed, your test cases get automated, and that's also linked in so that you have full traceability from the requirement to the function that's implemented to the final test that's being run. And doing this no matter whether or not you're building COBOL for a back-end application, or you're doing Java, or you're doing JavaScript or Xcode for your mobile application. So no matter what you're doing, manage all your source in a common environment, allowing your teams to work together to collaborate and understand the full life cycle. In this space, this is where we have Rational Team Concert, Rational Doors Next Generation, and Rational Quality Manager. And they all work together as part of the collaborative lifecycle management solution to provide this environment for your teams no matter what they're building. The next piece of this is making sure that your developers have a modern IDE and they can work together. If we think about the development process specifically on Z, in many organizations we're still using ISPF. And there's absolutely no reason that you need to be. Their modern development environment with Rational Developer for the enterprise allows you to do development in the same Eclipse-based IDE no matter what you're building, no matter what environment you're working for, and provides that modern tooling to allow developers to be able to do their job more efficiently with more capability than they could in a simple 3270 ISPF screen. Now, before you think I'm just picking on ISPF, I started my IBM career 27 years ago in ISPF development. So I understand that it has value and that it is an environment that users are very used to. But just because you understand it and you're used to it doesn't mean it's the right place for you to do development today. It's important to move to the modern capabilities so that you can do more and more efficiently. Next, we move into automated testing, functional testing, regression testing, and integration testing. And it's very important in this space to understand that there are different kinds of testing, and all of which need to be done. Starting with unit testing, building up JUnits and ZUnits for Z to make sure that you have the capability to test your environment in an automated fashion at the unit test level, building up functional tests, and then building up integration tests. And integration testing is part of the shift left testing. The sooner you can test at the interface level, the sooner you understand that the parts are going to be able to work together. If you don't integrate soon, early in the development cycle, then you end up with integration problems later in the cycle, which are much harder to fix. By focusing and having an integration test scenario early in the development cycle, you can ensure better integration, and you can ensure the function of the application sooner. The other thing to think about here is building up automated test buckets, if you don't have them, can be difficult. And so using a tool that helps you build up integration tests allows you to more quickly build up a set of test cases that at least allow you to test a percentage of the capability in the environment. Also, by using virtual services in the environment, so defining a virtual service, you can allow teams to do more testing without having the full environment available. So for example, you can define a JSON schema that is the interface between your mobile application and your back-end Z application. You can then define a virtual service and a test case based on that JSON schema, and then that can be used to allow your mobile team to do their development and allow your back-end team to have a test case to run the test to ensure that their application, their function, or service provides the data that's expected by the mobile front end. There are multiple different places where you can virtualize in the environment, anywhere that there is a service definition, things like web services, REST services, MQQs, even an exec kicks call in the environment, JDBC environment. So you can virtualize off quite a few areas of the application to allow you to do the testing how you need to do. And then as you move up the testing lifecycle to ensuring that you're doing user acceptance testing, et cetera, you'll add more of the real function into the environment. And then obviously in operations, you're running all of the real application rather than the virtual services. And next we get into deployment. One of the key areas I find working with clients is the fact that deployment across an application isn't done with the same tooling. So the traditional Z application is usually deployed with one set of tools. The distributed environment may be deployed with a number of different capabilities and maybe not the same that are used in the development or test environment. And even within Z itself, there are teams that use one tool to deploy the load modules and a different tool to deploy, say, the REST service files or the definitions, the new modern kicks capability to provide a REST interface or a web services interface, or even Java on Z being done in a different way. By using a tool that allows you to deploy no matter what platform you're deploying to, you have the capability to have a coordinated application deploy. And that's what I'm going to show in the demo. In this case, this is Urban Code Deploy, which provides the full support for your application, whether or not you're doing mobile or you're doing a back-end Z application. It provides that capability and allows you to do the deployment. So now I'm going to switch over to actually doing a demonstration because that's more fun than showing slides. And we'll go through and walk through the capabilities of a developer understanding how to do their application and then how to properly deploy it.
And so Rosalind, just one thing to the last slide that you were showing.
Yes?
That would be for Linux on distributed or Windows on distributed as well.
That would be for all platforms, whether or not it's Windows, whether or not it's Linux, whether or not it's ZOS, whether or not it's Linux for System Z. Any platform you're deploying to provides the capability to do that deployment. And the way Urban Code Deploy is set up, it has a set of plugins that allows you to deploy into the middleware, and I'll be showing more about that as we go through this demonstration. So hopefully you can now see my Eclipse screen, correct? Rhonda?
Yes, we can see it.
Ron.
Yes, we can see it.
Thank you. So here, this is actually a Rational Team Concert integrated with Rational Developer for System Z. And so this environment allows me to do my development, whether or not I'm doing Z backends or I'm doing distributed environment. I could have a Visual Studio IDE if I was doing .NET development. In this case, we have a simple environment called the Homestead application. The Homestead application is actually an application we use for a number of demonstrations. It is an iPad application that has a Bluemix mid-tier and a ZOS backend. And so in this particular case, we're looking at the source code for the ZOS backend. And in the RDZ environment, I have my source code open. This is a simple COBOL application. And you can see in the RDZ editor, it gives me syntax highlighting. It shows me how to do my development. All of the modern IDE kind of capabilities that you would expect. And I left in this error so that you could see it and identifies errors that you might have in the application. Now, I don't actually like to make real changes in programs when I'm doing demos, so I usually add comments to update things for the sake of not having to watch me do COBOL errors. But as you can see, this is a standard COBOL program. It talks to a database in the back end so it can get the data necessary for my application. So I've made a change in this application. But first, normally what I would do is I would have a work item that has been assigned to me to do a set of functions. And so based on a business request, based on a requirement that's been specified, there is a new function required. And here I have a work item that allows me to track the function that I have to build. I can track where it's being built, i.e. this is against the Homestead application. And of course I'm going to assign it to myself because I'm the one that has to do the work. And because we're going to finish this as part of the demo, I'm going to say it's high priority and current sprint. This is the work that I'm doing for this assignment, and I now have my task identified. In this program that I've just changed, I'm going to save the program that I just changed, and you notice in the bottom of the screen, in my pending changes view, I can now see that the system understands that I've made a change to this program. I've already loaded the source from the RTC SEM. I've made this change, and now I need to do something with it. I need to check it in so that I can go do a build or I can do what I need to do. If you notice, I'm working in my local environment, and of course, demos always have a problem. There we go. So I'm working in my local environment. So I made this change in my RDZ environment locally. So I need to check it in so I can go build this item, and I can do a personal build. And I need to assign this to the work that I'm doing. And this is the new item that I'm working on. So I assign the task. So instead of having to change flag my code, instead of having to do those things, RTC now tracks it. Now this item has been checked in, so now I could do a personal build and validate that before I actually deliver it. But since I happen to know that the coding change I made is not going to cause a problem, I'm just going to go ahead and deliver it to the stream. Here you can see I have set up a set of builds, and RTC provides a dependency-based build so that it will build only the changes that you just made. In this particular case, I have one program. I'm going to build that one program. And so I'm going to request that build. If I look at the dependency options, you'll see that I'm going to do a build, and it's only going to build the change items, and I want to just build the full program. You'll notice that there is an option to do build agent authentication override. As a customer, if you require users to submit builds with their own user ID, you can do that by specifying that task. You'll notice here that I have both a Kix build and a WS bind build. In my environment, I have a REST interface that's being defined against the Kix environment. And for the purposes of this, I generate the bind files based on my copybooks after the program is built. So I automatically kick off this bind program build to make sure I'm generating the appropriate files. So one build can kick off the next build. Another thing I want to point out as part of this build definition is we've actually created a post-build command line. And this is the integration into the deployment capability. So after I build this load module, it'll be turned over to the deployment capability in Urban Code Deploy to actually deploy this into an environment to allow me to then run the application. So if you look at the build now, you can notice that I'm now requesting a JSON build. And so it's going off and doing that secondary build. While it's doing that, you'll see in this case that I have a very simple environment. I have just these two builds because I'm working in a very simple kind of application. But to point out, in more common environments, you end up with more build definitions. And you end up with, generally you end up with things such as I need a dev build engine, a dev build environment, a test build. So I can have multiple builds in the environment that I may or may not be running. If I plan on not building post the first level, then I don't have to build post the first level, but I have the definition so I know where the data sets, where the files should be copied. As part of the build definition, all of the files are being appropriately copied out onto my Z system, and so they can build them appropriately. If you noticed, there was a little pop-up that appeared that said my build had completed. And so here, now I'm in my build. This is a build that I had one file to process, and I can easily look at the logs that have been produced. I bring the listings back into the RTC environment, and I can go see the build report. So I can go see, and I probably haven't logged in. And of course, in this amount of time, it will have logged me out. But what I do is I bring up, if I know my password, what this will do is bring up a build report, and if I don't get my password right again, what this does is bring up a nice build report, and the build report makes it clear what has been built as part of this build. So if you have, 5 or 6 programs, it'll tell you what's been built. It will also tell you why those things were built. And in this particular case, the source file had changed, so it was built. In some cases, it may be that a dependency for the source file has changed. A dependency changed in the environment. I changed a copybook, and I wanted that to be built. And so I would see that information. It would clearly tell me why I built this item. So now I have my source change that I've made, and I need to go deploy that so I can then go test it. And here I have my Homestead application in Urban Code Deploy. This Homestead application is composed of that set of parts that I told you about. It has the Kix backend portion. It has the web app portion, which is the Bluemix portion of the application, and it has the WS bind files. Bluemix, the Bluemix environment is a platform as a service environment that we have to allow you to build applications in the public cloud, to allow you to easily assemble your applications, provide the function that you need. In general, this case, it's being provided for systems of engagement. Since it's public cloud, you're probably defining your front-end application, your mobile application, to talk to your back-end system. In this particular case, this Bluemix application is connected to my back-end Kix using the secure connector, so that the front-end Bluemix application that's part of the public cloud is talking to my back-end Z application behind all of IBM's firewalls. If I go look at a particular component in this environment, and I look at the versions that are available for this environment, I'll notice that I have a new version that's been created recently that I can deploy into the environment. And so what I want to do is go back to the application and do a deployment, and then we'll show how this deployment happens. So in the environment, I can deploy any one of these. I can look to see what's been deployed in the environment, and I can easily see. This shows that these are incremental versions. On ZOS, we generally change a single file at a time or a couple of files at a time rather than a full application. And so here we can see each one of the incremental versions that have been deployed into the application. Here you see a specific version, because in this case it is a full application that's been deployed. It's all the files related to that application. And so it's a full version, and when we deploy it, we replace. So let's do this actual deployment. And in this case, I'm going to do a deployment. I'll do it with a test to see if it'll fail. And I'll choose the version I wish to deploy. And you can see here, if I needed to, I could deploy all of the versions for the application, so all the piece parts of the application, or I can deploy a particular item, and I'm going to deploy the latest available. And here I'm going to deploy that. And what it's going to do is go do that deployment. And as we watch, we'll see that there are a few steps that were not needed to be performed, i.e., I don't have to do the bind, the WS bind deployment, not the database bind, but the WS bind component, because that didn't get updated. And I don't have to install the web app because that didn't get updated. So what I'm doing is just installing that Kix portion. Let's go take a look at the process. We failed. We failed because obviously I messed up something in the application. Isn't this nice? Here is a failure that easily shows that the integration test failed because I changed something in the application probably earlier in the environment. And so what I've done is failed my integration test. So it's very easy to see that if you make a change in the application and you do a deployment, you can see easily whether or not that is success or failure. And let's go look at the process that I used to do this deployment to see what's being done there. Here is the application deploy process that I ran. And here you'll see that I'm doing the install the Homestead Kicks application, install the Homestead bind, and I'm dealing with the Bluemix portion of the application. We're going to focus on this piece. After I do the deployment of these pieces, you'll see I join these together and I run a set of integration tests. Assuming the integration tests are successful, and only assuming that they're successful, then I stop the stub that I have running, which is the virtual service that allows my distributed team to continue to do development while my back-end team does its work. Now let's take a look at this install Kicks process to see what we're doing underneath the covers there. That's defined at the component level, so each one of the components within this process I can define their own processes for. And here is how we're deploying that back-end Kicks application. Here you can see I'm doing a copy of the artifacts. That's bringing the artifact to the system to deploy. In this case, I'm using a copy because I share DASD across my Z systems, and I can copy this across. And in this case in particular, I'm on the same ZOS LPAR. And then I want to deploy those into a data set. And then I do my steps of the new copy for the Kicks application and the bind for the database. You'll see here that this is a run TSO or ISPF command. We provide a set of functions to allow you to do what you might need to do in a deployment. And so in this case, we're doing a command that will run a specific Rex program to actually do this bind. If we look at this definition a little more closely, you'll see that we're saying for any member with a deploy type of DBRM, so as you pass to Urban Code Deploy, you tell it what type it is, I want to do this process. So I want to say that this is a deployment and this is how I'm going to run it. And if you look at the bottom, you'll notice that there are a set of variables. And when you're doing deployments in Urban Code Deploy, you're going to use a set of variables that are defined on a per environment basis or per component basis so that you can easily have the same process used for all of your environments. Now, over here, you'll notice that this actually is a new copy. This actually is running a deploy type of new copy in the environment based on each member. And this is actually, over here we'll see, it's a set of Kicks plugins. These have been provided by the Kicks team, and right now they're still in POC, but we'll be GAing them soon, that allow you to deal with programs or web resource files, as in the REST files or the web services files. So the idea with this is that each of the middleware teams provides a set of plugins so that the deployment for the backend Z is much simpler and much easier, and you can reduce the need for Rex programs and reduce the risk. By doing a deployment in Dev, using this deployment tool, using this process, testing it out all those times that the developer is logically going to test it out because they're going to make errors in their coding. And then by the time it gets to integration test, system test, etc., you will have done this deployment numbers of times. So by the time it gets to production, you have the reliability and the understanding that it's going to be successfully deployed. You can do that with Rex programs, and over time, as we provide the middleware plugins, you'll be able to do that just with a middleware plugin. So we're specifically working with the Kicks team, the DB2 team, and the IMS team to provide the first set of Z plugins. Now, we also have a WAS plugin, so if you're using WebSphere on ZOS, we have a plugin already available that allows you to do deployment for WebSphere, whether or not it's ZOS or any other platform. And we have a set of other capabilities in the ZOS space. So as I scroll down here, you can see there are a number of plugins that are just base part of the product, base capabilities, and you can just download additional plugins for the middleware capabilities. And here, we're going to look specifically about the Z plugins, and you'll see we have things such as allocate a new data set, copy the artifacts, FTP artifacts if your systems are not interconnected. We have things such as submit a job. So if you want to submit a job, say you want to submit some JCL as part of the deployment, you can do that. And you can either submit the job based on the JCL sitting in a data set already configured, or you can specify it based on a file in the HFS system, or you can put inline JCL. You'll also notice here this replace tokens. This allows you to replace keywords within the JCL before it is run. So you can have a standard piece of JCL that's set up to deploy into the environment, and you replace the tokens when you run it based on the environment you're deploying it to. So you have the same JCL, whether or not it's dev, test, or prod, and the replace tokens handles that as part of the deployment. You'll also see that in this case, I specify that I want to wait for the job or not. So am I waiting for the job output? If I wait for the job output, then it will go and process JCL and then return, and then check the return code. If I don't want to wait, I can just submit the JCL, and later in the process, I can add this wait for job step. And so I can say that this is the next later step in the process after I've done a number of other things, and allows me to come back and say, okay, now that I've done those other things, I want to check on the output of this JCL. So it's up to you. You also notice here we have rollback data sets. So we understand that some organizations do rollback, and most people want to have the ability to do a rollback. And so we provide the capability to back up what is deployed and then provide the rollback to ensure that you can go back to the version that was there prior. You also see some kind of interesting items such as remove all versions or remove redundant versions. These actually are to indicate a way of cleaning up the system from a UI standpoint. Once you get to the point of saying, I'm not going to roll back anything before this date anyway, you could remove that from the visual so the user doesn't have to keep seeing the different incremental versions that have been deployed. And we also have the remove redundant versions to allow you to remove the versions that have been replaced by a later version. So since this is an incremental deploy, if I'm doing a deployment, and I'm in dev especially, I'm going to be replacing a load module over and over again. So there's no reason that I need to keep track, at least visually, that I've deployed all of those versions. Now, I'm not losing the history for anything. So I have the component history for all of the versions that have ever been deployed. So I'm not losing the history, the audit log, the tracking information. I'm just reducing the visual display when I look at my application here to show what's being displayed in this particular list, this long list here. So if I have lots of versions, I want to be able to show. One of the other very nice things in the environment is the ability to compare. I want to compare what's in production and what's in test. So give me a nice visual display of what's there. And I can very simply and easily see what's been deployed into each of the environments, and I can see what's been deployed in production that's not in test, or more accurately, or more normally, what's in test that's not in production. You can also see here, for example, with a full application deploy, I can see that I have version 25 of the Homestead web application in test, in production, and I have a later version in test because I haven't deployed that into the production environment. So it's a very easy visual understanding of what's been deployed to see what's going on in the environment.
Hey, Rosalind.
Also important to be able to drill down and see. Yes, go ahead.
Hey, I just want to add something out there tied back to your component process template that you were showing a minute ago for the plugin steps for some of our WebSphere friends on the phone. For the distributed platform, there's two components, the middleware configuration for WebSphere or MCWAS plugin, which will do the application discovery of the cell topology for WebSphere, and then there's a deployment template that has all the process steps similar to what she was showing for the JCL and the mainframe that would give you every step that you would need to just plug in some parameters for ear file deployment. So I know you didn't hit on that, but I wanted to do a comparison for those folks that aren't using the mainframe that might be interested in how those plug-in steps would play out for the distributed platforms, Windows or Linux, for WebSphere specifically and ear files specifically.
Yes, and they're plugins for WebSphere, they're plugins for MQ, they're plugins for lots of the different middleware components. And if you go out to the Urban Code Deploy website, you'll see lots and lots of plugins, so many that it's hard to keep up with all of them. And if you specifically think about the IBM middleware, they're actually going through a transition at this point in time. As I said, in the Z space, we're having the middleware teams build the plugins. And that's going to become the standard for many of these plugins. The team that builds the function is going to be the team that builds the plugin, which logically translates to the plugin will be built better to that application system and done in a way such that it will take advantage of the latest functions. So as the new functions come out in Kix or IMS, or once the WebSphere team takes over the WebSphere plugin, those kinds of functions, they'll take over, and then it's easier to see that the team that builds the application that's building the plugin for deployment ensures they're using the right APIs at the right level. We're also working very hard to make sure that things are supported at multiple levels, so it's not just the last version of something, but it's the versions that are in production in customer environments. The other thing I wanted to show here was you see the version label. This is mostly, well, in this case it looks like gobbledygook, but this version label is the build label. So it maps to the build that I performed in RTC. And so you can easily map between the build that was performed and the version here. We chose this as the integration point, as the choice to label the versions. You'll notice in some of the other items I had things like 2.3 or 30. We've chosen to number things differently in those environments, but you can choose what is appropriate for you and what is appropriate in the environment. Sometimes you map work items across. It depends on the environment. You'll also notice here in my version information, I have the information about what's included in this particular incremental deploy. So you can easily go back to any version and understand which load modules, which DVRMs, which JCL files, whatever was included in that deployment. And the same is true for other components. So if I pick on the WS-bind file item and I look at its deployment, and I go to its versions, and see it's had a lot of failures. I can see what's in its version as easily, and you can see this is a complete set of the files that are part of this Rust definition. And so you can easily see what's part of an application. In this case, it has this set of files. You'll also notice that this is a slightly different representation. I think it's important to point out that in these components that I have, so I have this Kix component, which is load modules. It is considered a ZOS component, and it's considered incremental. The ZOS components store their code repository, the built output on ZOS. The others of these are distributed components, or seen as distributed components. And so they're stored in CodeStation on the server. And here's an example that will look more like a standard distributed component. You see I have a set of files that are part of this application that are all of the pieces necessary to do my Node.js application. So depending on the environment, a Node application running in Bluemix, a set of REST JSON files, or load modules, you have all the information in the same interface, same way to get to it, same understanding. Go back to my deployment a minute, since I want to see what it did in the applications. We're going to go back to this deployment. And we're going to see my failed deployment. We're going to look at the process for the distributed side. So you can see that this deployment on the Bluemix side is actually slightly more complex, and actually something I didn't mention earlier, which was this add version. So one of the things that Urban Code Deploy allows you to do is process versions using an advanced version technology, or just basically let the tool update the version as it moves forward. And so in this particular case, because we're mapping the green route, we're doing a deployment to ensure that the Bluemix application stays live. We don't want to actually update the inventory version until we're ready and have said we've gotten to the green route. And so we've done this to add update inventory versions as a separate item, which you can do if you wish to do the advanced inventory function. Otherwise, you can simplify this by not adding that into the environment. And we can look at this deployment itself and see that the actual integration tests are not. Oh, we can see that the reason that the integration test did not run was because my test server is not up and running, not because the test failed. Well, that's a good way to discover there's a problem. So we can redo this. We can do this deployment to redo the deployment and update it. And so I'm going to redo the deployment so that everything is in sync. And this time, I'm just going to just deploy it. And I'm going to add latest available, and it's going to deploy, and we'll get a green deployment. So one of the other things I wanted to point out is, yes, now my deployment is successful because there was nothing to deploy because it was already all deployed. One of the other things that I wanted to point out in that process flow that I showed you was that we have the ability to integrate testing into the deployment. And so as you saw, I have an application, I did an application build, I did deployment, and I did my testing. Also, the process, if I need to just run them, so I have something in the environment that needs to have a run, that's not necessarily a deployment. I can choose to run a set of processes individually in the environment. Also see that I have a set of configuration environments, so I can define individual environments such as I have here, I have a test environment and a production environment. I want to make sure that it's clear that you have both of those and you can deploy to them. I can also do things like create a snapshot. So I can create a snapshot of this test environment, and then I can deploy that to the production environment, and therefore I'm deploying all of the same changes into the new environment. Now, before we end, I want to show one more slide. Oops. And that is a set of clients that have gotten value out of the capabilities and the DevOps transformation. And here you'll see a number of clients that have gotten success with their DevOps transformation, and I want to point out a few. So one, we have a nationwide example which has truly brought together their development environment to improve their development processes, to provide additional testing capability, and to bring their distributed and Z teams to work together so that they're doing development together. One example that's not on the chart that is an example for deployment would be Fidelity and their use of Urban Code Deploy to consistently deploy into their environment and significantly reduce costs by having a single deployment tool allowing them to deploy their application. You'll also see an example in here of the China Merchants Bank by using a common development environment, collaborative platform for development. They've been able to bring their teams together, to work together, to actually perform development tasks together so they don't have the team isolation, and allow them to get value and bring true profit to the organization by bringing applications to the end consumer faster in their environment. There are lots of other examples, both internal and external, of clients that have gained value. One of the things that's important to keep in mind that DevOps is a transformation, that all of the things that I've been talking to are transformations within the organization. It's more than tools, it's people and process, and people are very important in this, to have them understand what transformation is taking place, to make sure that they're on board with that transformation from the standpoint of they see the value. It's important that we do change because the technologies in our industry are evolving so quickly. With the Internet of Things, with the mobile devices, with many things that are going on in the environment, we have to react faster. We have to be able to react faster, and it's important to be able to do that. And the only way we're going to be able to improve the development process and be able to react faster is through automation and through ensuring that we have the continuous feedback, the continuous integration among all of the teams from development through operations to get the functions and the capabilities that you need. So no matter whether or not you're doing back-end systems of record, front-end systems of engagement, building APIs for the API economy, it is important to be able to build that, test it efficiently and quickly so that you can get the value out of the function.